The discovery of the Big Bang was revolutionary. But from the start, there was a nagging problem. According to the theory, the Big Bang made everything, all the energy and all the matter in the cosmos. In the modern universe, matter is concentrated into lumps, vast webs of galaxies, with hardly anything in the voids between. But the microwave globe Penzias and Wilson had seen showed no structure at all. And that's the problem, a big one. The microwave glow of the Big Bang seemed perfectly smooth, the same everywhere on the sky. But if that were true, then the universe that evolved from that Big Bang should be just as smooth, like this formless fog. So then, how did our universe come to be filled with clumps of stuff? Galaxies, suns, and planets. Maybe the early universe was not as featureless as it seemed. Maybe it contained some tiny seeds, little dense spots that gravity could shape into the cosmic structures we see today. Cosmologists figured that those slightly denser regions in the early universe would show up as bright spots in the microwave glow of the Big Bang. So they set out to find them. They would look and look and look for 30 years, and they would find nothing.
The astonishing thing is that the harder we looked, the more mysterious the universe became, because all we saw was a blank sheet of paper. Nothing was written on it at all. And we went down to a part in 1,000, it was a blank sheet. We went down to a part in 10,000, it was a blank sheet. It was at this point that my colleagues at Caltech started telling me that I was proving we weren't here.
No lumps, no galaxies, no us. That's what every observation of the Big Bang's microwave glow seemed to show. Either we just didn't understand the Big Bang, or secrets remained hidden within the microwave glow of the infant universe. Finally, astronomers wanted to settle the question once and for all. Flying above Earth's atmosphere, this satellite, called COBE, was designed to find the telltale bright spots within the apparently uniform microwave glow, if they were there.
As a member of the COBE team, we wondered all the time, would we detect this non-uniformity or wouldn't we? We thought that theoretically it should be there. For 30 years, people had thought that too and went out and made measurements and didn't find it. So we didn't know for a fact whether we'd see it or not. It was a crapshoot.
Main engine start, and liftoff of Delta 189 and the Cosmic Observation Background Explorer.
NASA launched COBE in 1989.
The solid rocket boosters have been jettisoned on time. All events.
It would spend 2 years in near-Earth orbit, observing the microwave hiss, the energy of the Big Bang, at hundreds of thousands of points on the sky. When it accumulated enough data, COBE revealed this. A blotchy pattern that doesn't look very dramatic to most people, but to astronomers, it was a revelation.
Well, we didn't, as some people said, see the face of God in the COBE picture. What we did see was a spectacular face of the early universe, which was just what we wanted to see.
This was what they had been waiting for. The blue colors reveal places where there's slightly more matter in the early universe. From these concentrations of matter, gravity will carve out galaxies and stars, suns and planets, and eventually, our home. In one brilliant stroke, COBE confirmed that the universe as we know it evolved out of the cataclysm of the Big Bang. But at the same time, it left much of the story untold. You see, COBE had a limitation, a kind of fuzzy vision. A COBE picture of me would look something like this. You can tell that you're looking at a face, but not whether I'm 20 years old or 60 or anything in between. It was much the same with Kobe. Its picture was too fuzzy to reveal much of what was really happening in the early universe.
It was as though we had seen the Earth and we knew there were oceans and we knew there were continents. But we didn't know how continents formed. We didn't know that there were mountain ranges. We didn't know that there were Grand Canyons, that there were polar caps.
The microwave background has encoded in it a tremendous amount of information about the properties of the universe. How old it is, what it's made of, how many atoms are in the universe, how fast it's expanding. And with the Kobe data, we couldn't answer any of those questions.
In other words, Kobe was teasing us.